Welcome to session 3 and to down the SI5351 rabbit hole. I hope you guys are all enjoying yourself and you've been able to do some things, play with some of the SI5153 that we did last week. This week we're going to talk about setting up a user interface for the ESP32, and we're specifically going to look at programming an OLED display so we can get some output to the user. And then we're going to look at reading a rotary encoder so that we can get some input from the user. So let's switch over to the presentation and I'll get it started here. And the first thing we're going to do is we're going to start out with a review of our goals. So our goals is how to interface with an OLED display, how to hook it up, how to use what libraries to use, and then how to send. We're only going to deal with text. There is a full-blown, if you look at the examples and the reference that I have in the slide deck tutorial on, what is it? Let me switch over here so I can see. On Random Nerd Tutorials, there is a, they show how to do graphics and just kind of give you the hello world to graphics. Then we're going to look at interfacing with the rotary encoder and how we can use that, and how this becomes those two items will become the basis, along with the SI5351, to build a VFO, a variable frequency oscillator. And we'll look at how we can use the switch on the rotary encoder to switch bands. And then that will in turn, well, I'm gonna actually write all that from the examples I'm gonna go through. So I don't know if we'll get through all that, but we'll try our best. So let's talk about the I2C connections again. So again, if for anybody that didn't make it to the last meeting, the I2C Serial Bus is what we're going to use, and it was designed by Philips back in 1982. Mainly to do serial-based communications between a microprocessor and other low-speed peripheral devices like OLED displays, LED displays, and actually the SI5153 actually uses it so that you can send commands to it to tell it what frequency to do it, what phase shift, and things of that nature. So what we talked about also last week in the last session is what are the pins that on the ESP32 that we're going to use for that. So we have our voltage into the I2C device. We're going to take that off of the ESP32 3.3 volt pin, and like the reference is J2 is the left-hand connector as you're looking down on the ESP32, and J3 is the right-hand set of pins. So we take that off of pin 1. Now, one of the caveats that you've got to remember is that if we add too many devices, you're going to have to look at providing a different voltage source, and so you'll want to run that to your ESP32 and then to each one of your I2 or I2C devices, so that they all are using the same ground and everything. Otherwise, you can get some noise in the line, and your devices will act erratically. We're also going to hook up the ground to the I2C device to pin 1 on J3, which is on the right-hand side. And then we have a serial clock line and a serial data line. And so we're going to use GPIO pin 22, which is pin 3 on jumper 3 for the SCL line. And then we're going to use GPIO 21, which is pin 6 on J3 for the serial data line. And that link down there in the bottom takes you to the getting started guide that I went through last week that gives you the breakout of each one of the pins. Let's see if I can find it here. So if you look down on the device, J2 is the one on the top here, which is to me the left because I'm always looking at it from the USB port, and J3 is the one on the bottom, which would be on your right. And the pinouts are down here on the header block. And again, if you'll notice all these ones here, like 16, 17, and 18, they've got the little tube by them. That's because they're actually used for other communications like flash memory and the USB UART. So we can't use those, but we can use pretty much anything else. And luckily, you can try different GPIO pins like 19, 18, or 5. We're going to actually use those this week for the rotary encoder. So let's go back to our presentation. There we go again, a better view of it so you can see it. And the ones I'm talking about you shouldn't look at using are the ones that have the exclamation point because they're shared with flash memory and shouldn't be used for regular GPIO. You do want to use one that is considered an IO pin, which means it allows input and output. So the ones that are green, like 23, 21, 22, 01, 03, 21, 19, 18, any of those that are in the green there, you can use those. I'm going to disconnect these pins here. Those are the ones that for the rotary encoder, since we're not going to talk with them right now. But the way I've set this up, try to keep my hands out of is that we've got the red guy going over here to the VN, which is this first pin. And then we're taking the ground, which is the black wire, which it goes to the second pin. And I'm going from right to left if you look down on the SI53. And then the SDA line, which is the blue one coming off here, was coming off of pin number 6, which is GPIO 22, and running into the SDA port. And then we have the orange one that's coming off of pin 3, which is GPIO 22, and it's running into the SCL line. Then the other 3 pins are your other 3 outputs for the chip. Now you can also mount SMA connectors on here if you're going straight out to an antenna or to another device. So these are actually mounts that you can actually use for SMA connectors. You can assign them on the board, or you can take that same signal off of the pins itself. Now, since we're talking about interfacing with the OLED tonight, what I've just done is I've just taken and piggybacked on those lines. So what I've got here coming off of the VN is into the voltage, which is the second pin from the right on the OLED display. It says VCC. And then the ground coming over to the first pin, which is your ground. And then we've got the orange line coming for your data, which is your third pin. Or no, I'm sorry, your second, that's the SCL, the SCL, the clock line is your third pin, which is the orange one. And then the blue one, which is your data line, is going to the fourth pin where it says SDA. So basically we're doing this in a bus configuration. So that what happens is when we send a command out to the display, it's going to take and I want to make that straight. My OCD is getting the better of me.
Ooh, thank you.
Should I pull it over a little bit too to center it?
No, it's fine.
Question.
Yes, sir.
This is Bill McNichols. Everybody else probably knows this except me. When I show up to the build, am I supposed to have this built like this, or do we build it?
Oh, we're going to build it. So our first day is show up with your parts, your breadboard, your wires, and we're going to go through and we're going to build this. We're going to do the calibration on the SI5153 chip, and then we're going to take it all the way to doing like the VFO, which is going to be the first part of our our little transmitter. So I also I am posting the code up on GitHub. So if you want to play around with it, you can, and that way, you know, you can, on your own, just so you're not waiting. But I figured we would not. I won't expect anybody to have done all this and be ready to go when we get at build day. It's more to teach you and to kind of go over it, let you play with it, and then we'll all convene and we'll answer questions and we'll get it, everybody's working. Does that help?
Yes, thank you.
Okay. Any other questions, guys, before I move on? Okay, let's move forward then. So I did a schematic. So let's bring that up for the display here. And just kind of what I covered earlier. We're coming off of pin 21. Well, we're coming off the voltage, the 3.3 volts, and we're going into VN on the 5351 board, and we're going into VCC on the SSD1306 OLED display. Then we're taking the ground and we're running into the ground pin on the board and on the ground on the OLED. And then we're using pin 21 to go into the SDA on the two boards, and GPIO 22 into pins or into the clock lines. So this is kind of the circuit I have displayed over